think we're live, although it's, oh wait, maybe now. Still very stationary. So I want to wait and make sure we're actually doing something. There we go. I think we are now actually doing something. All right. There's a longer delay than normal today. Today, what I thought we'd do is we would look, at least for part of the time, at the Benchy, since I do have you print that as one of your, or as the thing that you print over and over again, kind of to improve on. There's a whole suite of other prints that you can print, but this is the one that you kind of repeat. It is not the only, and it's maybe not even the best calibration or benchmark print, but I do like it. For one thing, it's not just a random assortment of overhangs and columns and everything, and so it's a little more interesting to print, and it does give you some good information about the big settings in your printer. First of all, if your printer can just print a Benchy, which it should be able to do that. It may not look very good, but it should be able to print one. So we're going to go through and look at some of the things that I look for when I'm grading these Benchies. Now, there is a 3dbenchy.com website where you can go and, let's see, where's it at? I think measure and calibrate. You can go in and they tell you all the dimensions of particular features on a Benchy. I usually don't do this. Well, for one thing, during the summer when this is online, I don't have a good way to measure, any of these things. I'm looking at pictures of your Benchy, so I don't really have a good way to measure all these. But if you have a caliper and your Benchy, then you could go in and get some of these measurements and see if your printer is calibrated that way. Typically, I don't do that just because I'm more interested. Oh, well, there's one of these that I look at. Where's it at? This one. I look at the roundness of the smokestack. That's not necessarily the dimensions of it, but if it's round versus oval or some other shape. That one, and I look at this box to make sure it's kind of square. Well, rectangular. I don't think it's actually a square, but it has right angles and the walls are more or less straight. So I do kind of look at those, but I don't measure them. What I do look at is, let's look at some of these that I have printed and see what sort of features I do look at. So these are three. This is that PETG carbon fiber. I think it was called smoke blue, maybe. I think is what they called it. Smoke blue carbon fiber PETG from Atomic Filament. I don't know if they actually sell that on the package. It says it was, I think it's the one that says it was specially colored just for the maker box. I kind of like this color more than the just plain black carbon fiber filled PETG that they have. So I haven't looked to see if they actually have it for sale or not in this color, but I do like this color. This is just a PLA. It's actually from a different printer, but I had it handy, and it does show off one of the things I want to look at. This one is, I sped it up a little bit to print it slightly faster, and it's in that orange zero filament that we've been using for this course. So the things that I'm looking for when I print one of these, or when I'm looking at one of your Benchies that you've turned in and I'm trying to grade it, what I'm looking for first is I look at the bottom, and there should be text on the bottom. None of these have particularly good text. This one you can kind of, you can see it just in the different way the light's reflecting. What this tells you is if your nozzle height is correct. None of these are particularly correct. This one is too smushed. The text is about gone, in fact. Sometimes I'll look at pictures of them and the text is completely gone. But what I generally want to see is not this, where it's very stringy. This one, the nozzle is too high. This one is really close. It's going to be hard for you to probably see. Maybe if we zoom in a little bit and focus on it. You can see the text is in there. This one's a tiny bit too high. Because you can see gaps in the layer that it laid down on the bed. I would rather have that a solid layer versus being able to see the gaps between the lines in there. Also, it didn't resolve the middle part of the D and CT3D. This one did, but this one's really squished also. So you can see it right there. It is in there, but you can just barely see the text at all. So between these two would be ideal. Now, obviously, all three of these actually printed. They all completed, so they all were good enough. But this one being too close, that bottom set of layers is going to be a little bit wider than what you intended for them to be because they're squished down. But if you are having trouble with print sticking, then you'd rather have a little more squish than not. So it is a handy thing to be able to do. This one, PETG, a lot of times you don't want to squish it down too much because it does have a habit of sticking a lot to surfaces. I did print this on glue stick, and it wasn't on a glass or a PEI sheet. It was just on the basic Ender 3 bed, so it wasn't that much danger that it was going to stick permanently. But a lot of times PETG, you don't want to squish it too much. And maybe I over unsquished it. I had a little bit too much gap there. I probably could have gotten away with a little more squish on that one. This one I printed at a faster rate, and it just kind of jumbled everything up. In fact, this one, while it was printing, I did go in and adjust the bed manually, turning the bed knobs underneath it a little bit just to try and get it to stick a little better, because it was, I printed this one before this one, and so I don't think I had reset the nozzle height. Speaking of that, next time on Monday, we are going to put our BL Touch on this one so that we have a little more automation in our leveling and bed probing and everything, so maybe that goes away a little bit. The changes in height, or it's a little easier for me to control anyway. So you can kind of see where it's just all jumbled up. So I would say none of these have a great first layer on it. And sometimes that's necessary. Sometimes you have to have a really tight first layer just to get the print to stick down. Sometimes you want a little bit looser first layer because you don't want the material to stick, particularly with PETG. Other materials don't quite adhere that much, although to perfectly flat, clean glass, a lot of materials will stick pretty strongly. Particularly if you did something like this on a clean glass plate, most materials you'll have a little bit of trouble getting off of there. If you get it stuck and it's on glass, one thing you can do that will help is just wait for it to cool down. So a lot of times when you're still trying to remove the part and it just printed, almost all materials are going to stick pretty strongly while it's still warm. So let it cool down. And if that doesn't help it release, put the whole thing, assuming you can take this glass, if it's a piece of glass, you should be able to take it off the printer. So take the whole thing, put it in the freezer for 10 minutes or so, and a lot of times that will change the plastic material enough compared to the glass that it will pop off of there. I don't have it anymore. I think I threw it away finally. But I've had material, just plain PLA, stick strong enough to a glass sheet that it pulled chunks out of the glass, and so it can be a little bit of a problem if you get too much squish on one of those perfectly flat glass sheets. But I do like printing on them. I don't know if I bought one for this printer or not. I don't think I did, but we could always put one on there if that's interesting. But I hope to put the magnetic sheet on today. All right, so that's the first thing I look at. I look at the bottom just to see if your nozzle height is looking more or less correct. So these are probably the two extremes of correct that still work. You can certainly squish more, and that's going to probably create bonding issues. It's too well stuck, and that first layer is going to get really deformed because you're really squished, and probably not just the first layer, several layers. And then this one is about as far off the bed as you want, much more away from the bed, the nozzle away from the bed, than what's producing this kind of pattern. is going to lead to the chance that the part's just going to come loose during the print, and then you've got nothing. So that's the first thing I look for. The next thing I usually look at is if I'm grading one of these. The next thing I look at is usually if there's ghosting or ringing. So the best one of these prints that has that is this blue one. And it's hard to see, and I'll try to get it on camera. Maybe if we change some exposure here, we can see it better. Nope, not that way. I think if we're darker, we might be able to see it. Oh, I might have to draw it in because it's really hard to pick up on the camera. But typical places, assuming you put your Benchy in on your print bed in the normal orientation and you didn't, change it somehow, then right around this, what's this called? A hawse pipe. It's where the anchor comes out. You'll see little artifacts. This one I'm tracing the artifacts so you can see them better. This one actually has quite a lot. All of these marks I made are on top of ghosts or ringing from the print head having to come around this rim. And so if you think about it, the print head's moving around and it has to make a little bitty outward and then quick back in to make the rim here. And when it does that quick change, it oscillates until it settles back down. And you can usually see it right here. You can usually see it around here. Maybe you can actually see this one. It's pretty strong. I don't know if you can see it on the camera or not. Yeah, you can kind of see its shadow right there. There's a artifact right around here from having to print. Same thing. There's this rim around the door, and it's having to do that same movement where it is printing and then it jumps back in really quick and it oscillates a little bit. And so that you can usually see it there. Sometimes you can see it around this one also right here. There's some artifacts ghosting right here. There's some. Those are usually, you're either printing too fast for your setup. Now these two were printed at 50 millimeters per second, and this one was 70 millimeters per second. All of them on Ender 3s. This one was on a slightly different Ender 3 though. This one actually, it does have ringing a little bit, but it's actually less than this one. So this printer, the one that we just built, actually has a little bit more stable mechanism than this older one. I don't remember this is probably the one from last year. So one thing is print speed will affect this ringing. The other thing that will affect it is if you have a loose belt somewhere. So that's the other, we want to install this guy shortly, maybe even today, depending on how long we have. But something that you have a little bit more control over adjusting the belt tension. I do want to put a similar thing on the front, so the belt that controls the bed also. In fact, usually the ringing is the bed moving. So this is going to be for the carriage moving, where the hot end is. Most of these, if you look about, this boat was sitting this way, and the bed, it's having to move back and forth like this, and that's the direction that most of this ringing occurs. Now this one, why it doesn't have quite as much of that, and I just thought about it, I printed it this way on the bed, so it wasn't in your normal orientation. I rotated it 45 degrees, and so coming around these corners, the bed is moving, but the carriage is moving also to create these shapes, and so it minimized ringing a little bit. Because I didn't have any surfaces that were really in any primary, like just the bed moving didn't create any of these shapes. It had to move in concert with the carriage. So that's a thing you can do without changing any settings, is orient the part a little bit differently, and that can have an effect on surface quality just because it's not relying on just one motion to create that. Sometimes that's good. If you're creating a bunch of straight lines, then put those straight lines in the same orientation as one of the axes, usually not the bed axis, because the bed is the one that's going to have the most mass and it's going to be the hardest to accelerate and decelerate and change directions and all that sort of thing. So if you can put your straight lines in the direction of your X carriage, you know, the where the hot end is, then that's probably going to produce better results. So that ringing, you can always just slow down. You can work on belt tightening. There are some settings that we can do, acceleration settings in the slicer. Let's look at the slicer for a second. I think I have it pulled up. We can look for, let's see, enable acceleration control, and then I have all of these accelerations, and there should be some jerk settings in here too, so I guess I'd have to search for that. I don't have any of them like enabled to where I can just see them all the time. I have to search for them because there's a lot of them. But you could change these acceleration values, so how fast is your printer trying to go around corners and change directions and things like that. And if you lower them too much, then all of your sharp edges will get rounded out, and you won't have quite the detail, but you will have less of the ringing after you change directions. 500 is on the low side already, so I don't think I would lower these much beyond that. There are jerk settings also. Jerk acceleration is the derivative of, you know, position change of speed, and then jerk is the derivative of acceleration. So enable jerk control. These are all also pretty low, 8. I probably wouldn't change those. So these are kind of already set. These are the default settings for Cura's Ender 3 profile. I haven't changed them on this one. And if you are having some issues that you just can't get rid of some of the ringing, these could be an issue. A lot of times these, particularly the jerk and acceleration, not just the speed overall, but the jerk and acceleration will give you layer shifts if they're too high. You're trying to change direction too fast and your steppers just skip some steps or whatever, and you'll have entire layer shifts. I don't have an example of that with these prints. These didn't really do that. But those are settings that you can look at. Generally, first thing to look at is make sure you have belts that are tight, and you don't have any real slop in the belt. Obviously, those will create all sorts of artifacts in your print. So check for belt tightness. Maybe slow down your print 5 millimeters per second, you know, something like that, and see if that helps. Change the orientation of the print possibly to get a better surface finish without ringing. And these are essentially the same printer. They're both Ender 3s, but they are different printers, different instances of the printer. And just changing the orientation and printing 20 millimeters per second faster, I have much less ringing on this one. Now, this one has other problems, but I have much less ringing just by changing the orientation. The PETG, I don't see any ringing on it. So again, these two were printed on the same printer, and this one was not printed. Wait, this might have been the one. Maybe both of these were printed. Now I don't remember. See if I can. Yeah, actually, this one was printed this way. This is the one that I printed at an angle, and so maybe this printer is just kind of better tightened down than this one was. This one, I don't see any evidence of a ring. I see other problems, but not ghosting or ringing on this one. And so belt tightening, maybe printing a slightly bit slower if your belts are tight. Another thing, you put a glass bed on the bed of your printer. That adds a lot of mass to that. You know, it's a nice surface to print on, but it does add a lot of mass, and so that can also create ringing, particularly if that the belt connected to your bed is a little bit loose. So look for that. Then another thing I'll look for is in the windows, like here and here, here, and here. You've got a little bit, there's bridging all over the place. Usually the best sample of bridging, how well your printer is printing in midair from one point to another, is this line right here. And this one's actually really good. These two have a little bit of a droop. You can you can see it right there on that one. See, it's a tiny bit of droop right here. Technically, the whole bottom side of the top is printing in midair, but it's really hard to see in there. So I usually look at this line. This one has a little bit of droop. This one has a little bit, it might be a little less. This one almost has none. And so what's controlling your bridging is your slicer does have bridging settings. Enable bridge settings. Oh, wait, hold on. There we go. Enable bridge settings. And there are a set of settings that you can go through for changing the bridge settings. Usually the most direct thing that you can do is make sure that your cooling is adequate for most of these materials. You do have the settings you can change, but they're usually, the biggest thing is, are you cooling the material well enough as it's printing so that it actually doesn't have a long time to droop. So I would say that these two, the ones printed on our printer from this year, are almost okay, but this one is better, and this one does have a different cooling duct on it. And I'll show you the difference. Let me find it. It's on Thingiverse. Sometimes Thingiverse is picky on searching for stuff, but it's this style right here. So the default Ender 3, if you have the Ender 3, then your default Ender 3 is basically just this little nozzle here. This one actually takes and it puts the air coming from the little fan, and it puts it much closer to the actual printed part. Also, it keeps the air from accidentally blowing on the hot end. So it does two things at once. It redirects the airflow right to the part you just printed, and it kind of encircles it a little bit, at least halfway around. And the other thing is it keeps that air off of the hot end, or the nozzle in particular. Now most of the printers have some sort of silicone sock around the hot end, the heater block. So they're pretty well insulated already, but this does keep a little stray air that would try to cool it away from that. And it directs that air straight down onto the part you're trying to cool. And so the one that, the blue one, has this kind of nozzle on the printer that printed it, and the other two have the stock air duct on it. And I do like this one. It just, you take the old one off, these little tabs right here, screw it together. It actually kind of clips in place, but there are screws that hold it. There are much fancier ones, obviously. A lot of times those are if you want to change the fan itself, maybe get a larger fan or whatever. This one, the other reason I like it is it uses the fan that's already on the printer, and it does a good job in general. But there are, like I said, some much fancier ones, and they do work well, but you have to purchase a different fan to go with them. Let's see. Back to here. So I'm usually looking for drooping. Usually, if you don't see the drooping here, then there's almost always a little bit under one of these, just because it's having to print in midair. You can kind of see a little bit here. Another sign of cooling / retraction is going to be all of the strings in here. And this one, yeah, you can see them down in there. There's a bunch of little strings down in there. And now these are not a problem. If you just kind of even touch at them, they pull off of there, or take a heat gun or hot lighter or a hair dryer and wave over it, and they'll pretty much disappear. This one, again, this is PETG. Same printer as the orange one. It doesn't actually show much stringing at all. And typically PETG is kind of stringy, but this particular one that has the carbon fiber in it probably makes it a little less stringy anyway. And so I don't actually see any of the retraction style stringing. This kind could be adjusted with retraction settings, or a little extra cooling would help. So I think on this printer, maybe one of the next things we need to print is this, to get a little bit better cooling on our parts, particularly if we're going to print parts in materials that need cooling. PLA usually needs cooling. If you want the nice surface finish. If you want strength, then less cooling will actually be a stronger print. But PLA sometimes with less cooling has trouble maintaining a good surface finish. It melts a little too much. So then what I look at, I generally look just to see on this nameplate on the back, if you can discern that it's even there. First of all, this one is almost gone. So this one, you can kind of get a hint of it being there. Again, this one was printed at 70 millimeters per second, so it's printing faster. But it's almost gone there. This one's actually decent. I can even read most of that one. This one's actually really good. It gets a little fuzzy over here on what I'm trying to read. I don't know if you can see it just because of I'm trying to look at it on the camera. But in real life, you can on the camera, it doesn't even look like it's there. But in real life, you can see that pretty well. I don't know if I can get enough. It's not going to really pick it up. Maybe right there you can begin to see that it's there. Though in a picture, this is also a tough one to read because photographing and getting enough contrast on these letters is sometimes tough. I wonder if I can shade it in. You can see it. You can begin to see it a little better, even in person. Can't really see it very well on the camera though. You could probably fill in the words there. It's supposed to say hashtag 3D Benchy. On a little plate the plate is raised out and the letters are inset. So it's going to be hard to read that. You can kind of begin to see some of it there. But what I'm looking at there is, first, did it just resolve it? Did it print it at all? Now, if you're printing large layer lines and fast, it probably isn't even going to resolve. I don't usually count too much off of that, just because it is very difficult for one of these printers to resolve that well. And then for you to take a good picture of it that shows it off, I don't count too much. As long as I can kind of see it there, then that's usually what I'm looking for. Other small details though, you got this little flagpole or flag stand, this little drain, or maybe that's where the prop's supposed to come. I don't know what that's supposed to be. But you've got those. Notice these did not resolve as well. On this printer, they're not quite circular. They're a little bit oval. This printer is it's actually smaller and a little more circular. So these have some potential. Now this printer has not been fully calibrated. Remember, we just flashed firmware to it, and so it might not be fully calibrated yet. I haven't redone the PID tuning. I haven't redone the flow calibrations, where this one does have all of that done. And so you can kind of see that they're not quite round. This one is kind of messy. It's kind of jumbled up all in there. Again, this is PETG, and it does have some trouble resolving smaller details in that material a lot of times. These PLAs do have a little bit better job of resolving small features like that. And so those settings are just, you can kind of get some flow rate ideas. You can, in these, since they're oval, you have to think about how these prints were made. These are circles, yes, but they were printed one line at a time. And so I probably have a little bit of flow calibration to do on this printer because I haven't done it at all. And E-steps would also account into flow. So that's probably why these are not quite the correct shape. It could be, it is usually not, but it could be that the Z-axis is not moving up the right amount. To do that, that would be one time where you measure this height. I'm really zoomed in right now. Measure this height and see where we're at. You know, go back to our measure and calibrate page. Again, I can't do this when I'm judging yours from a picture. Should be 48 millimeters. And let's see what we're at. So, actually always zero your calipers. Make sure they're at 0. And let's see where we're at. We're at 48.05. 48.05 millimeters. So we're pretty much on the right height. So that makes me think it's not a problem in Z, it's a problem in X and Y, which is usually going to be some kind of flow rate type thing. Possibly a belt that's not behaving right, but these don't show any real ringing, which makes me think the belts are fine. So there might be a little bit of flow calculations that aren't right on that. Another thing I look at is on this, and this will show you if your belts are have a issue. If this is round, if it's not round, then you're getting some kind of extra slop in one direction, X or Y, and these all look pretty much round to me. Also, if they're just kind of melted at the top, this is the last thing that gets printed, right? And so the nozzle prints, moves up, prints, moves up, prints. If you don't have enough cooling on that, then this hot material on top of more hot material on top of more hot material, it will just kind of deform these. These all look fine. This one does have, and now this one's printed the faster one, and it does have a little bit of a issue down in here where it's not quite the same cylinder, but this one was printed faster, and so I think just slowing it down would have done better. You can also check your flow rate here. So on the tops of this, you can sort of see. Let's see if I can get it to where it, I don't know if you're going to be able to see it. And that's the only one it shows up on. What you're looking for on the top of here is any kind of gaps between the walls. These are basically just walls. There's not an infill here, unless you only printed with one wall or something like that. And this would be the top of it anyway. But if you see a gap here, then there's a good chance your flow rate is too small, and you're not putting out enough material, and it's printing the two walls side by side, but they're not actually merging together because they're too thin. And you can usually see it in here. Sometimes you can also see it on top of the smokestack. Usually you can see it on this top of the box somewhere. If there's a gap between any of those walls, if you see a gap in there, that's a little indicator that your flow rate's a little too low. Let's see, what else do I usually look for? I usually look at the hull in general and see if it has blobs and zits and things like that on it. This one has a couple down here, little blobs. It has a gap right here, but this I caused. So this one is the PETG, and I was printing it and I realized that I didn't turn the fan off. I didn't lower the fan. It was going at 100%, and I generally like to print PETG with a little bit lower fan, and that's the point where I changed the fan during the print. And I think that little bit of having to communicate, send this little blip of extra G code in there probably affected the print itself. And a lot of times that's what these zits are. Now these are not. These are something different we'll talk about in a second. But a lot of times just random blobs here, they can be a communication issue. So maybe you're using Octoprint. We haven't really talked about that yet, but maybe you're already using it. Or maybe you're printing over a USB cable or maybe your SD card is kind of full or whatever, and any kind of slowdown, any kind of thing where your printer has to pause, or the controller has to pause and think about a command or process a G-code command to get it to move stepper motors around, anything like that, that little tiny pause doesn't stop the printer from being hot and doesn't stop it from having filament in it. Even if you're not extruding filament, it will, kind of blob out an extra little ooze, a little bit of filament. So a lot of times if you see blobs scattered around on the surface, it might be some sort of communication issue. And in general, it occurs more on curved surfaces, because the way these slicers work is they don't use curves. G-code doesn't, or it does have a command for creating arcs, but none of the slicers I know by default will use those arcs. They use just lines. And so instead of this being a curve, it's actually a whole bunch of straight lines. And the more curves that you have, the more little tiny line segment commands have to be sent to your controller, to your stepper, and actually move. And so that's a lot to happen in a very short amount of time. And any little pauses in that chain of reading the G-code, interpreting the G-code, sending the right pulses to the steppers, and all of that can result in little blobs. And that's really bad if you're printing over a USB cable, because the cable itself limits that sometimes. And Octoprint, your internet connection can limit that sometimes, your local internet speed. Not necessarily to the internet, but your wireless connection. It doesn't go to the internet, it stays on your local wireless. But that all of those things can cause these little minute pauses in your print, and they're hard to track down if you don't know to look for it. So it could be something related to processing the G-code. I've had several students who, for whatever reason, they were just printing over a USB cable. They didn't want, maybe they didn't have a USB card at the time or whatever. They had lost it, and they were using the USB cable to send the G-code to the printer, and that cable had issues. Or maybe the computer running it would start up a new program at the same time and take a little bit of processing power away, or speed, communication away from that USB cable temporarily. And it would show up as bulges in the side of the printer. Now these here, you can probably see, yeah, you can see those. That is something different. This is the Z-seam. So every one of these layers is a flat layer that has a starting point and an ending point, and that is where the layers started and ended for this boat. This one, they're back here. You can kind of see them. This one, they are also on the back corner over here, but they're much less noticeable. So on a printer that's had some tuning done to it, on this starting and stopping of a layer, you'll get a little bit better result, and not quite so bad of a line like that one. That one's pretty prominent, and they also show up on the smokestack pretty well too. Right there, you can see them, or I can see them. Looks more like a highlight on the picture. Here you can see them. Look, they're right there. So that line right there. You do have a couple of settings in your slicer that will not eliminate them but hide them. So if you look up seam, and there is the Z-seam alignment, you've got shortest, random, sharpest corner, user specified, and you can try a different combination. Well, so for instance, right now, let's slice it where it's at, I guess. All right, so this is with it on the back left, and you can see all these white dots. That's where it's going to create the seam. And so in this case, it's creating the seam kind of in a hidden place versus out in the middle, versus something like random, where they're just going to scatter these dots all over the print. They're scattered around. Now, it might be, let me show you this. It might be that you don't have the starting spots marked on your preview. If you don't, and you're in Cura, if you go to this color scheme, you can click Starts, and it will show you where it's going to start at. You can also turn on Travels. That's usually not useful, although it'll give you an indication of where stringing might occur. See where it's traveling all these blue lines, and it's just moving in midair from one point of the print to the other part of the print. Those are potential locations for stringing if you don't have your cooling and retraction set well. I usually don't have that on though, but a lot of times I do turn on Start so that you can see where it might put the Z-seam. I usually don't like the random because instead of having one place where they're all kind of located, it kind of makes a little textured surface all over the place. So I don't know if I normally do shortest though. I don't even know if I know what shortest is. Let's see. In this case, you know, they're kind of scattered around on the back. They're all lined on this edge here. That wouldn't be horrible. They're kind of scattered around on the smokestack up here. But you can play around with that. There are tuning you can do on some printers. Some printers can't handle it. There's a linear advance or pressure advance that will basically predict when you're about to end a line, and prematurely, well, not prematurely, but before you're at the end of the line, it will release some of the pressure of extruding filament and kind of let it coast to the end. Well, and there is a coasting. I wonder if coastings. There is this coasting set that is in Cura that it's experimental. I don't use it much, but you could kind of coast to the end of a line and try to reduce some of the effects of a bulge around a corner, because you're kind of you're slowing down but still extruding, and sometimes that'll cause a bulge, or these little Z-seam things. So coasting, you could try it out. And again, it's in their experimental, and you can do that through the slicer. You don't have to go into your firmware to change anything. Some of these pressure advanced, linear advanced, they have to be done through firmware, and some boards can't handle them. It's a lot of extra processing power. But coasting does a similar thing through the slicer. So it does it on the front end versus doing it live during the print. So you could try that. Let's see. What happens if I enable it? I'll try it out at some point and print one and see if we can notice a difference. These are just the default settings. I haven't actually changed them at all. But you can see now, instead of just the white starts, there's a little gap right before them, or right next to them basically, and that's where the coasting starts. So it actually stops extruding filament right here, so that this little spot where it could have an overlap between the start and the end point, it kind of coasts into that end to try and minimize the effect of that bulge. And so you have to do a lot of tuning to get, you know, how much coasting do you need to not have a bulge and not have a gap, because you can have too much coasting and this gap will actually show up and you'll have a bunch of holes in your print versus a bunch of zits on it. So that is a way. Those are two ways. One, you can just arrange the Z-seam to be hidden better, and another is you can turn on this coasting and fiddle with it to try and actually eliminate the dots for the Z-seam. What else do I look for? I look at the hull in general and just see if there are any layer lines out of position. Now, there's almost always going to be a line. These don't actually show it too bad, but maybe you can pick it up there. I don't know. I don't know if you can. I don't think you can. But if you look at your personal Benchy that you've printed, you might be able to see it right there. There's usually a line right here, or a set of lines right here, that kind of stand out on your print. You can kind of see them right there. What that is that's where this starts printing the deck, and then you can also usually see it up here where it prints this forward deck up here. And so beneath that, unless you've been printing this thing solid, then it's a bunch of walls with infill. And then at this point, it's solid all the way across. And it's not a thing you can necessarily calibrate. You can reduce it a little bit by having more walls on the print. So maybe 4 or 5 walls, you can kind of hide it a little bit. But it's a fact of, or it's not a fact, it's a phenomenon of transitioning from a hollow part to a solid part. And it just shows up almost inevitably. There's not a lot you can do to remove it. So that's not necessarily what I'm talking about, although these printers are doing a pretty good job of not showing that. Different materials will do better at not showing that also. But what I'm really looking for is entire layer lines somewhere that are kind of really out of place. Even these, if they're really out of place, then you probably have over extrusion, maybe under extrusion, but usually it's an over extrusion problem, which is E-steps and flow rate type stuff. Sometimes you can't get rid of them entirely because it's not a slicer, it's not a hardware issue, it's just a phenomenon of empty space with solid space on top of it, that it just doesn't create a great transition between those on the outside. Let's see, those are the main things that I'm usually looking for, and I'm looking for a complete Benchy, it didn't crash somewhere through. These walls here I usually look at their surface finish. Sometimes none of these actually show it too bad. This one kind of begins to show it. Sometimes you will see kind of like a stripe pattern on here and a diagonal angle, kind of like that. Sometimes maybe it's going the other way. I don't remember which way it goes. I can't see it on any of these. That is not necessarily a slicing function, but more of a function of your stepper motor controllers themselves. So the actual drivers for the stepper motors and the way they work. Again, you can kind of reduce the sight of those with the filament. If it's not a if it's a kind of a filament like this, it's sort of matte, they don't show up as bad. If it's a slower print speed, you might not see that as bad. Sometimes it's just worse, and it's not the infill, it is artifacts of the resolving how to print these lines. Your stepper motors do move in discrete steps. Even if they're tiny steps, they are discrete steps, and you can see that pattern somewhere. It's usually not as prominent on modern 32-bit boards. The older 8-bit boards tend to show it a lot more. There's also another feature that none of these are really showing, and I don't see as much anymore, called salmon skinning, where if you think about the like salmon meat, it has this pattern, these pattern kind of like this in it, and you can kind of see something like that, not quite the same as these diagonal lines. You can sometimes see that particularly in the hull. None of these are really showing that off. And these are all 32-bit boards, and 32-bit boards don't show that as much as the older 8-bit boards do. Maybe the last thing I look for is this area right here, to make sure that you don't have a drooping line or two right here, which would just show that you're not cooling well. So several things related to cooling, several things related to flow rate, a couple related to you're just printing too fast or too slow, and then is your printer more or less calibrated, no loose belts, things like that. These prints, they're a little bit lengthy. Maybe I was printing, this one was at a faster speed and it was a little over an hour, but I was using multiple walls. I think like 4 top and bottom layers and maybe 4 walls, where you can certainly print them with fewer walls and lighter infill. I use the gyroid pattern on this. Sometimes if you use one of the more regular patterns, that pattern can show through the wall of your print, if you don't have many walls. And the gyroid pattern doesn't seem to show through as badly a lot of times. So those are the things particularly when I'm grading one of these Benchies. Those are the things I'm looking for. But if I'm printing one just for my own sake, I'm trying to get an eye on how flow rate is doing, how's cooling doing. Do I have anything that looks like it's loose? Do I think I'm printing too fast, or can I speed up and print a little bit faster maybe? Things like that. They're not, purpose made for this particular thing, but they are a benchmark, and there are many of them out there that have been printed that you can look at and see what other people have done. All right. I think what I want to do is, we have a few minutes. I'm gonna put that magnetic bed on, because we haven't done that yet, and I kind of want to do it, and because I want to use it, and I didn't want to install it and then not show you what is involved in installing it, although there's not really a lot involved in installing it. You take your old bed off. Now, this one, in most of these magnetic beds, they do stick down to here. So one thing that can be a problem, I haven't had it be a problem, but the screw heads here for the bed screws are here, and it is possible that this screw is going to turn when you go to try to tighten or loosen. Maybe you change out something down here. It's possible that this is going to turn and it's going to be covered over. So I have never had that be an issue, but it is a potential issue. If you're worried about that, you could maybe drop some super glue on here. If you really get into it, you could always cut the little hole out here and tighten it down if you had to. Probably don't need to clean this because it hasn't really been dirty, but we're going to wipe it down with some IPA because we are going to put an adhesive on it. Here's our bed we're going to use. Here's the sticker, and it's just a 3M double-sided magnet. Well, not double-sided. Oh, well, I guess the adhesive was double-sided. So we're going to try and line. Now, one thing on this, do be careful. If you get it really crooked, this magnet is going to hit the rails. So you do want to get it pretty close to straight. I can't see it. In fact, I'm going to do this edge so I can see it better. That looks good. All right. So we'll put that down. Now, see the screw holes are covered up. If you ever need to, you got to cut a hole or try and peel this back. If you peel this back, there's a good chance that it is not going to go back down flat. So if you did have to get it to that screw, I think I would rather cut a hole here to access it versus trying to peel this up. And then what you have is this, where there's no more of these, so these aren't in your way anymore. And this stays put pretty well. You print on it, then you can easily pull it off, and these are spring steel, so you can flex and a part will come off. This is a PEI coated one, so you do want to be careful. Again, PETG will sometimes stick too well to this PEI, but you can print on the other side if you want to, and it's just steel. And you might have to put some glue stick or something on here to get it to stick. I don't often print on the plain steel side, but you could. You can still, even though there's a sheet of magnet on here, you could still put your glass bed on top of this if you wanted to switch from here, printing on this, to the glass bed. It was the biggest thing that's going to do, though, is it's going to add more thickness, so your Z is going to be off if you're not using some sort of automatic sensor. And it's going to add even more insulation between your heater and the top of the surface. So you're probably putting glass on top. You need to bump your heat up maybe 5 degrees. Putting glass and this magnet on top, you might have to go maybe 10 degrees hotter than you normally print on the bed. just because you have two insulators on top of it, and it's going to be tough to get all that heat through. I do like these though in general because of the PEI. With most of the materials I print, they stick really well to the PEI, and then you take it off, that lets it cool down really fast, and you do a little flex and the part slides off. Also be careful when you're putting the bed on, because you put it crooked and it'll hit the rail. Hopefully you're not that careless though. But I have put one on just off enough where it rubbed a groove in this plastic housing for the power supply. This one has plenty of clearance on both sides though, so I don't think that'll be a problem. I think we have enough time to also do this guy, so we can get all kinds of upgrades today. This one, again, this is, I don't remember, I have to look it up. Let's actually look it up and see how much it cost. I think it's in the $20 range, but I don't know. Let's see. Let's see. $25. That's on sale a slight bit. I don't remember shipping. I think when I order stuff from here, I usually order enough that it's free shipping. Free shipping on $50 or more. So you'd have to order something else if you wanted free shipping on that. $25. That's, you know, that's a reasonable price for a magnetic bed. This is not particularly high or low. I don't know that you can find much lower, cheaper ones. You can certainly find more expensive ones. All right. So let's get this part. Let's see if I can get a picture of it. There we go. So we're going to replace this. Oh, I also printed, I have to shift you around. I also printed a little tool holder up here. Kind of keeps all your tools handy. Not 100% if I like it or not, but it does keep everything handy. So I like that part. So we're just gonna, remember this has those T-slot things, so we just have to loosen these a little bit. And then the belt is gonna slide off of there. And you've got this. And then we replace it with a new one. Oh, but we, let me figure out, how are we gonna, oh, okay, there's a screw here that we need to get the belt around this pulley. So we've got to do something like this. And then put it back together. Lost one of our screws. Okay. That doesn't seem like it's binding anywhere. Wow, we're losing everything. Fortunately, we have another set if I can't find it. Well, I did find it. That's the annoying part of these, is that they have to be sort of loose. And apparently I had that one too loose. So there we go. Make sure your belt doesn't get all twisted up. And you might think that you have to slide these T things in, the T slots, but you don't. You can just push them in, line them up with the opening and push them in that way. Let's actually release the tension on this so I have more slack. It was all the way tightened. Whoops. There we go. Now let's put that kind of there. Now you do have to make sure that these actually catch. Oh, these are smaller. Because it's possible that you tighten these up and all they did is, let me show you. All they did is tighten against themselves. So if these T's don't swing around to catch in the groove, then you can tighten it all you want to, and all it did was tighten against itself. So it'll feel tight, but it didn't actually do anything. It's still sitting there, you know, sideways. So you do want to make sure that it actually caught in the groove. I think I dropped, what did I drop? I don't remember now. Oh, I dropped that thumb screw. We'll have to find that. All right, so I'm putting it farther out at the end so I have more. This is run all the way in this way for loose. So I've put this as far that way as I can, and still have something for the screws to grab onto. And then when we tighten, that'll give me the most amount of room for tightening. All right. There. And there. And I do need to find the thumb wheel. It rolled off somewhere, and I may not be able to find it just yet. But it goes here to actually do the tightening. Without that, it doesn't do anything. Oh, shoot. Here it is. All right, and so now you have a lot more control on how much tension you want to put on this belt. They do have 3D printable versions of this. You know, right here. There's a, well, that's for a CR10, but that would also fit a Ender 3. They do have them for the belt associated with the bed also. Here's one for Ender 3. And so you do use some of the old parts. These bearings here are, you can use, I think you can use these from your old part. And should be even be able to use that screw. And then there's one for the bed. So they do have some that you can just print. I haven't ever printed one of these. Maybe I should print one of the ones for the bed since I don't have one for down here. I don't have one for down here. This one's usually easier to adjust by hand anyway. Plus, this one comes already assembled on most printers, and it's usually fine. But there's more room to get in here and loosen these and apply some pressure to tighten the belt and tighten it up. But that one would be a good one to print, and we could test it out. All right. Next time, what are we doing next time? Next time we're doing the BO Touch. Next time we're gonna install, and this is the one that I have. We're gonna put the BO Touch on there. This one. I probably got this from Amazon, I assume. I don't really remember. It doesn't say anything on here where it came from. But this is one from Creality. Let's see what all is in this one. Some of these come with mounting hardware. Some are just the BO Touch, and some are knockoffs. This one should be the actual Ant Labs BO Touch, but I don't know. Let's see. We get a yeah. This one has the mounting hardware, the BO Touch itself, plenty of different cables for things, and it also has a way to connect it. Now, some of the older boards needed you to actually tap into the wire here that was controlling the beep on your screen, and some of the newer boards have a place where you can plug the BO Touch in directly. We'll have to see which our board has once we get into it, but we'll install that on Monday, and we'll get it, hopefully get it running, and usually they're not very difficult to set up. There are a few tricky parts that are hard to track down, and so hopefully we'll have good luck with ours and get it. We will get it installed and working. I don't know if we'll get it installed and working in class. All right. I will see you guys on Monday. Let me know if you have any questions about stuff. Hopefully you got a little bit of hints on just why you're even printing these things, things you can do with them, and things you can do to get your printer to print a little bit better. Again, on these upgrades like this, you don't have to do any of those. I'm just showing you how you install them, what they do, and where you can get them if you want to, if there's something they're interested in. You can print forever on a plain Ender 3, no upgrades at all, or maybe print a cooling duct or something like that and be fine, perfectly fine. So some of these are just quality of life. Like I like the bed because I can take it off of there, pop the parts off, and get it back going without a lot of scraping. Usually there's no scraping. You usually don't want to scrape on this surface anyway, and so it just makes things a little bit simpler to do, but it's totally can be done without it. So they're just ideas that show you different things you could do. All right, I will see you guys on Monday.